So building integrated photovoltaics and building attached photovoltaic, they both carry some new issues for building fire safety. For example, they are electrically active elements. So for firefighters or other people that it's going against the fire, when they throw the water and so on, could be a new risk that other materials in cladding system does not have.
Yes, and besides, we have also the issue that the fire ignition itself can start from the PV module, and this cannot happen in the building products. So this is something that we should look into more in detail.
And that's why in the task 15 B1 subtask, we are trying to address these new issues. We have organized our work in 2 steps. The first step will be to analyze the framework and the regulations that we have in the world. So we have partners from Asia, from the USA, and from Europe. And we are analyzing the regulations and how each different country address these risks. And then as a second step, we want to go one step further, and we want to see also the members of this subtask that has our own labs and also our simulation tools. We want to see how we test these systems in the labs and how we simulate them, if we are able to address this new risk, or we need altogether think how we should define new testing protocols and add this part to the regulations. So in this B1 subgroup, we in the first analysis we are doing about the regulation, we have seen that there are not many countries with specific regulation related to BIPV or BAPV. We have seen that Singapore has some issues that are addressed.
Yeah, and all the testing methods that we have seen that usually are applied in these countries are not adapted to these PV modules. So, for instance, these testing methods are not done having the PV modules active while we have the fire tests. And we don't consider that the fire source, the fire ignition, can be the PV module itself. And yes, this is something that we want to analyze in this subtask.
Yeah, and that's also why Technalia is involved in several Horizon Europe projects. One of them is Mass IPV, and we are here in EU PVSec also with one poster related to this project. And in this specific project, we will address the topic about this internal fire source, and we want to create a protocol where the fire will not be external fire source, will be an internal one, a smaller power of the fire, but it will be located in the gap of a ventilated facade. So we will check if the impact is high enough, and we will see if we will give some clues to the regulators that maybe they should include this in the new regulations.
Yeah, and internally also we will present another poster, which is about the work we have done in Mesteroi Horizon Europe, where we set up a new pilot line to better assess BIPV products. We defined new testing procedures for aging sequences or optical measurements, and in the case of fire safety, we have defined a new testing method to simulate indoors in a laboratory how the sun could affect to a fire tests. So we defined electrical configuration to create or to have these modules active while doing a fire test to see if there is an impact, if a PV module that is outdoors under the sunlight, if this could be damaged by a fire, if the sunlight would have an impact in the damage of the PV or not.
Mm-hmm. And that's how, step by step, also in task 15, subtask B1, we want to assure that PV systems are installed in a safe way.